The essential question today is how do I use set theory? Okay, the V in Venn diagrams is always capitalized because it's actually named after the mathematician that developed them. Okay, the D in Venn diagrams can be capital or lowercase, that doesn't matter. Yes, sir?
Are you going to be like looking for the difference between capital V's and lowercase v's?
Yes. No. When you are using someone's name, you have to capitalize the V. Yes. It matters. Okay. A set is a collection of objects or numbers. We use braces around the set and commas between each item in the set. And we name these with a capital italicized letter. Now it's really hard to write italics when you're writing. Of course, if you've got a computer, then it goes a little easier, but actually doing italics is not easy. Do your best to slant it. We can have set A with a circle, square, and triangle. And I could have set B with 3, 5, and 7. In Algebra 1, you dealt with replacement sets. You were given an expression like 3x minus 2 and asked to find the range for x equals -2, 0, and 1. So you substituted in each value of x, you chugged out your answer. Okay, that was the replacement set, the values you were substituting in. An element is that a semicolon or an I? That's a semicolon. An element is an item, usually a number, in the set. We do have a symbol for element. And the symbol looks like a capital C with a bar in the middle. Yeah, that's an element symbol. I could say that square is an element of set A. And 5 is an element of set B. A set that has no elements is called an empty set. You can show empty sets either by using braces with nothing in between, or by using the empty set symbol, which is a 0 with a slash through it. Slash doesn't look so very good. Another name for the empty set is the null set. The state of Virginia uses the phrase empty set. Every college textbook I've ever looked at uses the phrase null set. Just know both. Sets A and B are equivalent sets if they have exactly the same elements. With sets, we're often showing the relationships. So one relationship is union. That's the set consisting of all the elements in set A, all the elements in set B, or all the elements in both sets. There are two symbols. The first symbol kind of looks like a widened uppercase U. And the second symbol looks like an uppercase V. Both symbols will be on the test, the quiz, and the SOL. Intersection is the set consisting of all elements common to A and B. This is where the sets overlap each other. Okay, the symbol is the inverse of union. So literally, if we turn the U upside down and the capital V upside down.
Yes. So for the U and the V, are each of them symbols of union, or
Yes.
together are they?
Each separately symbols of union.
And they both mean the same thing.
They both mean the same thing. Both of them can show up on the test or the quiz or the SOL.
For equivalent sets, do the numbers have to be in the same order?
Or say again?
For two sets to be equivalent, should the elements be in the same order?
No, they do not have to be. Is Kendra? I'm sorry? We'll see that in a couple example problems. Okay. The set containing all of the elements in our problem is called the universal set. The symbol for the universal set looks like a capital U with a tag on the front. Subsets. Set A is a subset of set B if every element in A is contained in B. So if set B is all geometry students at Luther Jackson Middle School, and set A is my 7th period geometry class, then A is a subset of B. You're a part of a whole, and every single one of you is contained in that whole. And the symbol looks like a stretched out capital C with a bar underneath.
Wasn't the subset symbol right?
There's another symbol for it. This is the one we're using right now. Okay. The set of all elements in U not in the given set, that's called the complement. And we have some options for complement. You can use the prime. You can use a capital C. Both the prime and the capital C are raised up like exponents. And there's the good old tilde coming back to be useful in yet another context. And all of this gets related by Venn diagrams. It's just a diagram showing the relationships between your sets. They're a lot of fun. Alrighty, so how are sets drawn? We draw our sets with figures called Venn diagrams. And there are two main types of Venn diagrams. The first one shows disjoint sets. Sets where they have no elements in common with each other. When you draw Venn diagrams, you must box in the universe for that problem. Okay, and my universe in this problem is going to be LJMS. Set A is going to be 7th graders, and set B is going to be my 8th graders. And you can't be both. You're one or the other. So they're disjoint. They have nothing in common with each other. And out here we also have teachers. They're part of the LJMS universe, but they're not part of the 7th grade set, and they're not part of the 8th grade set.
Do the teachers have a disc?
No, they're part of the universe, but they're not part of the sets. Now, if we have elements in common, we have overlapping sets. And with overlapping sets, you have probably seen 2 circle and 3 circle overlapping sets.
What's the universe for this one?
Haven't decided yet. Let's make the universe 0 through 9. Let's make set A the evens. So 0, 2, 4, 6, 8. Let's make set B multiples of 3. So based on our universe, what multiples of 3 do I need to include in this set? Right?
3, 6, and 9.
3, 6, and 9. And let's make set C multiples of 4, which based on our universe is going to be multiples of 4. Chris?
4 and 8.
4 and 8. Now, based on my verbal examples here, right, I've opened up a whole range of prior knowledge things to go after you for. Knowing factors, multiples, prime, composite, whole numbers, natural numbers, integers. Lots of things I can do with vocabulary here where I don't list it, I tell you what should be in it. All right, so the easiest way to do this is to literally run through our universe. 0, does it belong to any other set? A only. So 0 will go up here in A only. 1, does it belong to any other set? Just the universe. 1 is floating out here in the universe. 2, does that belong to any other set? A only. 3, does that belong to any other set? B only. 4, does that belong to any other set? A and C. So it has to go where A and C overlap each other. Be careful not to put it where B overlaps. So it does not go in the very center. It goes here where only A overlaps C. 5, does that belong to any other set? Nope. Floats out here in the universe. 6, does that belong to any other set? A and B, so it belongs here where those two overlap. 7, does that belong to any of the sets? Nope. 8, does that belong to any of the sets? A and C. 9, does that belong to any of the sets? B. Okay, and I've successfully placed every element of my universe in the correct portion of the Venn diagram. So, how do you read set notation? And what do you have to know about it? Lots of good stuff. In particular, this diagram. You need to know how to read it, how to symbolize it, and what it looks like in terms of a Venn diagram. So to begin with, we have A union B. They didn't give you this option. And they left that out down here too. Okay, and that's everything in both sets. So everything in both of the circles. Intersect, only the overlapping part is shaded. Complement. Notice the C is raised up like an exponent, but the tilde is just in front like normal. So complement of the set containing 1 and 2 would be everything except the set with 1 and 2. Okay, you can subtract sets from each other. When you get more than one operation, the complement of the union of A and B. Follow order of operations. Order of operations, you would do the parentheses first. So in this case, you have to find the union first, which would be everything in both of the circles. Complement means everything else. So we shade everything that's not in both of the circles. So union. How do we draw unions of sets? The key word for union is or. You heard the word, excuse me, or in Algebra 1. I'll give you a hint. It's from the inequalities unit. What did or mean in Algebra 1? Grace?
It would be like for less than or equal to, or more than or equal to.
Okay, it showed up there. Where else? Michael?
In quadratics, when x equal 12 and the coordinate equal.
Yes? Ayad? Uh-huh. Okay, so you said x is less than or equal to 0, or x is greater than 3. What was that called? A disjunction. Vocabulary from Algebra 1. Alrighty, so we're going to do A union C. Our universe for this problem are the digits 1 through 9. So when I draw this, I've got A and C and the universe. Now, looking at A, 2, 4, 6, 8, looking at C, 5 and 7, are there any elements in common between A and C? No. So I don't want to put anything in the overlap. 2, 4, 6, 8 in A, 5 and 7 in C. Then I have to go back and make sure my universe is accounted for. I'm missing 1, 3, 4, 5, 6, 7, 8, and 9. Now for union, I need every, oops, that's not the right one. Edit, undo. I need every element in both, which means I need to highlight both sets. Please do not shade with hash marks in your pencil. It's too hard to read. Break out the highlighters and color. Don't care what color highlighter.
So we highlight it?
Yes, please. It's much easier to read than shading with your pencil. That gets to be in a
for two other things.
You're going to need the highlighter the rest of the notes, yes.
So what was the reason why?
Because that's the answer. Okay, the answer is everything in these two sets, and we have highlighted the answer. We can also write our answer in what is called roster form. 2, 4, 5, 6, 7, and 8. This is called roster form. And you should always put the numbers in order, least to greatest. If they're letters, alphabetical. If there's something else, something that makes sense in terms of organizing it. Sometimes there is no sense to be made. B union C. Do I have any elements in common between B and C? Yes, ma'am. 5 and 7. So that has to go here where B and C overlap. B also contains the elements 1 and 3. And then I have to account for the rest of my universe. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I'm interested in the union again. Now there is another way to draw this one. Because C is a subset of B. Everything in C is also in B. So I can contain the circle for C inside my circle for B. 5 and 7, 1 and 3, 2, 4, 6, 8, 9. Two different ways to draw it. They both have the same meaning. It's up to you which one you use. And roster form here would just be 5, 7. Oops, 1, 3, 5, 7. So looking at my intersection. Okay, A union B. Do I have any elements in common between A and B?
No.
No. And so another way we could have drawn this first one is to go ahead and draw them as disjoint sets. Since A and B have no elements in common, I could draw them that way. 2, 4, 6, 8. 1, 3, 5, 7. 9's floating out there in the universe. And when I shade in my answer, I'm still shading in both of the sets. 1, 2, 3, 4, 5, 6, 7, 8. A lot of fun to be had with Venn diagrams. Michael?
If we run out of space on our paper, can we continue to the next line of subset?
I don't understand what you're meaning.
Like,
if you're writing the roster form, could the 7 come down here?
Yeah.
Yes. Alrighty, for intersection, let's get away from numbers and do some letters. Alrighty, so how do I draw Venn diagrams using intersection? The key word here is and. No idea why I put a second blank. It's a typo. So this was disjunction for or, and graphed like this. What was that word? X is greater than 0 and less than or equal to 3. Michael?
line segment.
Conjunction. And don't tell me you didn't learn it last year, it was on the test. Oh, and you didn't do well on the test because it was on the Unit 6 test. Alrighty, A intersects B. So do I have any elements in common between A and B? I sure do. C and E are in common, so they have to go here in the center. Let's see, we also need a lowercase a in set A. We need a lowercase d in set B. And the universe contains the letter B. Now for intersection, we're interested in that little sliver right there, where the two are overlapping each other. And our answer will just be the letters C and E, the elements the two sets have in common with each other. For the next example, A intersects C. Are there any elements in common? Yeah, A. Now I could draw these as overlapping sets, Or I could say, well, A is a subset, I'm sorry, set C is a subset of set A. Every element in C also happens to be an A. So I could draw it as concentric circles. So A, C, A, C, E, B, D floating out there in the universe. When I color this one, I'm only interested in what's in common. Okay, when we had union and we had concentric circles, we colored all of the circles. But with intersection, you only color that innermost circle. Michael?
With the intersecting circles and letters as the data points, how would you tell the difference between C as the circle and C as the set element?
It can be challenging, which is why I use different colors. Yeah, so if that happened to you on a test or a quiz, I would break out the pens or the colored pencils. All right, B intersects C. Do we have any elements in common? No. I could draw it as overlapping sets, or I could draw this one as disjoint sets. And B contains C, D, and E. And C just contains A, with B floating out here. And because I drew this as disjoint sets, there's nothing to color. There is no overlapping area or point of intersection. If I drew this, this is the empty set. If I drew this as overlapping sets, I would have to color this empty section right there. Okay, so there are options when you're drawing these sometimes, and how you shade depends on which option you choose. Next up, subsets. There are two types of subsets: proper subsets and improper subsets. Improper subsets are my favorite because they're the same as the set you're given. The set I'm given here is 5, 7. That's my improper subset. Got that part down. Proper subsets can be a little more tricky. You have to look at every possible combination. All right. So there's no other way to just write two numbers, but I could separate each element out, and I always have to include the empty set in any list of proper subsets. Not bad at all if you only have two elements. Let's have some fun. Proper subsets. And we'll use set A over here, because with 4 elements, it is more fun to do. Now, the improper subset would have all 4 elements. As I go to do my proper subsets, I have to do every combination of 3 elements, every combination of 2 elements, every combination of 1 element. That's what makes it more fun. So, 2, 4, 6. 2, 4, 8. 2, 6, 8. 4, 6, 8. Being very organized about how you approach this makes a huge difference. And that's all of my possibilities for 3s. Let's do 2s. 2, 4. 2, 6. 2, 8. 4, 6. 4, 8. and 6/8. And we still have to do the ones. So, 2, 4, 6, 8, and the empty set.
I just started the 2s.
So this can get pretty ugly pretty quick, depending on the number of elements you're dealing with. I will never give you more than 3 elements on a test or a quiz to do this with. Okay, I will limit the elements. Giving you something like 10 elements could take you all day. But this can get pretty nasty if there's a lot of elements in your sets. Huh? Alrighty, on this one I want to add a D. And I want to add a set of 0. And I'm actually going to change this one right here to D. Alrighty, so this is a true or false question. Is A subset of our given universe? Is every element in A also in our universe? Right? True. Right? 2, 4, 6, 8. They're all there. Is B a subset of our given universe? Yes, that's true. Is D a subset of our given universe? False. 0 was not in our universe. So D is not a subset. Is C a subset of B? Is everything in C also in B? Yes. What do you think this symbol means? Not a subset. Right? Just like the slash through equals means not equals, and the slash through congruent means not congruent. Most mathematical symbols, if you slash it, it means not whatever the symbol means. Most of them. This one's tricky. Is C not a subset of A? It's true. Nothing in C is also part of A, so that's true. Now there's a couple of very simple proofs you're asked to do with these. In this case, I want to prove that 5 is an element of C. So we start off by listing set C. If I want to prove 5 is an element, 5 first has to be a subset. So 5 is a subset of C. Therefore, 5 is an element of C. Okay, the 3 dots, therefore. So what do you think the slash through the element symbol means? Not an element. You got it. Thomas, question? Italics, yeah. Microsoft Word at its finest. They should be. Is 5 an element of A? No. So 5 is not a subset of A. Therefore, 5 is not an element of A. Okay, the complement of a set. Remember, we can write that as the set prime, or the set complement, or not the set. A couple of options there. I was taught prime, so that tends to be what I default to. Yes, sir?
For the not subset, did it lose the bar?
Yes, it does. Alrighty. Couple of options. I can put set A and the universe. I do not need to clutter up this Venn diagram with sets B and C.
Is that a apostrophe E comma or a semicolon?
Where?
In A and AC.
It's a comma, because I'm listing things. You could put sets B and C on there if you really want to, but they're not necessary. Alright, set A has 2, 4, 6, and 8. The universe includes 1, 3, 5, 7, and 9 in this example. And the complement of A will be everything not in A. So that's one way to do it. 1, 3, 5, 7, 9. Another way to do it is to draw your Venn diagram and actually label the set the complement. That means I want all the elements of B out in the universe and all the elements that are not part of B in my complement of B. So 1, 3, 5, 7 are part of the universe, but 2, 4, 6, 8, and 9, all of which are part of the complement of B, to be inside here. Different ways of drawing it, and what you do really should depend on what you need. I think we're close to being done. C prime. And I'm just going to write out C prime. C prime included 5 and 7. So 1, 2, 3, 4, 6, 8, and 9. But I'm actually going to do the next one because I've got two operations going on here. I need to do complements and I need to do intersection. You have options. My preference is to figure out what the complement of B is and what the complement of C is, and to put that in my diagram. Because I want where the complement of B overlaps the complement of C. So the complement of B was 2, 4, 6, 8, 9. And the complement of C was 1, 2, 3, 4, 6, 8, 9. Okay, my intersection. 2, 4, 6, 8, 9. B doesn't include anything else. C includes 1 and 3. 1, 2, 3, 4, 5 has to be in the universe. 6, 7 has to be in the universe. 8 and 9. And I want the intersection. More than one way to draw that. Some ways are easier than others. Union and intersection are commutative. Whether you say A union B or B union A intersects B or B intersects A, same thing. It is associative, but it has to all be union. or all be intersection. You can't mix and match. So you can't combine union and intersection and group the parentheses differently. So I can have A union B union C, and A intersect B intersect C. Alrighty, you need a summary and a bunch of questions. And then we continue with all of this on Wednesday as we hit truth tables.